Question number 51. Percentage purity of 150 gram of CaCO3 sample which gives 5.6 liter carbon dioxide at STP on complete decomposition is. In this case, we have CaCO3, calcium carbonate sample, and it is on heating gives CaO and CO2. Now, you have the amount of this CO2, that is 5.6 liter. How many moles of this would be there? Given volume divided by 22.4. So, we will find out the moles of CO2. Those would be 5.6 divided by 22.4. And that would be equal to 0.25 mole. Now, these are the moles of carbon dioxide. Now, as per the given chemical equation, you will identify that 1 mole of CaCO3 is giving you the 1 mole of CO2. It means this 0.25 mole of CO2 if produced, it means this should be 0.25 mole also. It means if we compare the moles here, now you have on the basis of this the moles of CaCO3 that should be taken. If it is 100% pure, then the moles should be 0.25 only. On that basis, its weight should be 0.25 into 100 moles into molar mass. Then you are getting here 25 gram weight. But no, you are not taking this 25 gram, you are taking 150 gram. It means this calcium carbonate is not pure. We have to find out its percentage purity. This 150 gram of calcium carbonate is acting like 25 gram of calcium carbonate. So, percentage purity, amount of pure sample divided by the amount of impure sample you are taking here into 100. And if you solve this, you will find out this value would be approximately 16.67%. And yes, if it is the answer that's given in option 2, we'll choose this as the correct option. After this, it's a turn for question number 52. Now, question number 52. Consider the following statements and predict the wrong statement. Basically, in this case, we have to read all these given statements. On the basis of this, we will choose our correct option. Let's check statement A. Half-filled and fully filled orbitals have greater stability due to greater exchange energy and symmetrical distribution. We all know that it is a true statement because in case of half-filled and fully filled orbital, there would be the greater stability, and that is due to greater exchange energy and symmetric distribution, and the statement is the correct statement. Further, we have the energy of 3s orbital is less than p orbital of hydrogen atom. So if we talk about uni-electron system like hydrogen-like species, in those cases, the orbitals which are present in a particular shell have the degenerate energy. It means if we talk about third shell, so the energy of 3s, 3p and 3d would be equal. While if we compare it with the second shell, in that case, that 2s and 2p will have less energy as compared to 3s, 3p, 3d. It means the statement that's given here as the statement B is the wrong statement. That states the energy of 3s orbital is less than 3p orbital for hydrogen atom. Further, the uncertainties principle is delta E into delta T, that is less than or equal to h by 4 pi. This is also wrong statement. I'm just writing here the correct statement. The uncertainty principle can also be explained as delta E into delta T is greater than or equal to, not less than, equal to, greater than or equal to h by 4 pi. So this statement is wrong. Further, E is equals to minus 2.178 into 10 raised to the power minus 18 z square by n square joule per atom can be used to calculate the change in energy when the electron changes orbit in hydrogen atom. Yes, this formula can be used because it is representing the formula for the calculation of energy of nth shell. And if you know this formula, with the help of that, you can also find out the change in energy when an electron changes its orbit. From certain orbit it is coming to the next orbit or the previous orbit. In that case, you can use this formula. It means this statement, that statement D, is also correct. Now, which of these statements are incorrect? Statement B and C. And where these are given? This is given in option 1. That's why this 1 is our correct answer. Further, the next question is here. Question number 53. Maximum 2 electrons can be associated with quantum number n is equals to 3, L is equal to 1, M is equals to -1 in an atom. The above statement is in accordance with, we all know that the statement that is given here, that quantum numbers n is 3, L is 1 and M is -1. This is in accordance with Pauli's exclusion principle. What that principle states? It says that no 2 electrons can have the same set of all 4 quantum numbers. If 2 electrons have the same set of quantum number for n, L and M, then definitely their spin quantum number would be different. It would be +½ for one electron, -½ for the next electron. It means 2 electrons cannot have the same set of all 4 quantum numbers. And that is Pauli exclusion principle, not this n+L rule that is used for the filling of electron. For the Hund's maximum spin multiplicity rule is also used for the pairing of electrons in the orbitals. So this is also not correct. Further, Aufbau principle is also related to the filling of electron in the orbitals. So this is also not correct. Which statement is correct? Option 1 is correct principle, and that's why I'm choosing it as the correct option. Let's take next question. Question number 54. The orbital angular momentum of S electron is. How do we calculate orbital angular momentum? Orbital angular momentum is equal to root L plus 1 H by 2 pi. This is the formula that we use. For S electron, if we are talking about to find out this orbital angular momentum, what we need the L value, and for S electron, the value of L, that is azimuthal quantum number, that is 0. And definitely, if it is 0, this orbital angular momentum would also be 0. Because if you place the values here, you will find out that this value is 0. And that's why option 4 is the correct option for this particular question. Question number 55. Which of the following set of orbitals may have electron density along the axis? We have different orbitals given here, and we have to choose that set in which orbitals are present. They have electron density along the axis. Let me mark here. We want to choose those orbitals which have electron density along the axis. We should know that this pz orbital, dz square orbital and dx square minus y orbital, they have the lobes along the axis. And if they have lobes along the axis, definitely there would be the electron density. We have drawn the structure for these orbitals here. For the pz, I've drawn here. This is along the z-axis. While if we talk about dz square, there are the 2 d orbitals which are along the z orbital. There are the lobes of d orbitals which are along z-axis. That's why electron density would also be there. Further, we have dx square minus y square. We can clearly see that the lobes are there along the y-axis and the x-axis. That's why electron density would also be there. And on that basis, this is the set of orbitals that have electron density along the axis. But we have to check further options also. dxy, in this case, electron density is between the axis. This dxy has the lobe between x and y axis. That's why it is not the correct answer. For the py is given, dx square minus y square is given, and dyz is given. So if we talk about dyz, in that case, the lobes are between the axis. That's why electron density is not along the axis. That's why it is also the wrong statement. Further, dxy, dyz and dzx. In case of dxy, lobes of orbital are between x axis and y axis. For dyz, the density is between y axis and z axis. And for the dzx, in that case also the lobe of orbital is between z axis and x axis, and that's why electron density would also be between axis, not on the axis. That is why this is also not the correct answer. So which option is correct? That we already chosen here. That is option 1.